4.6. Congruence in right triangles. For number 1, are the two triangles congruent? If so, write the congruence statement. So these two triangles are congruent by the hypotenuse-leg theorem. But looking at our choices, we gotta make sure the letters are written correctly, meaning each letter corresponds correctly with its corresponding angle in the other side. The one that does that is B. D, E, and F, and G, H, and J go in the same order of corresponding angles to angles. And that is number 1. Number 2, complete the flow proof. So we're given CM and ZM are congruent to each other. We're also given CR is perpendicular to RH and ZH is perpendicular to RH. And we're given M is the midpoint of RH. And we gotta prove that these two triangles are congruent to each other. So the first thing we're given is this, which is part of our given, so choose that. Now we're told that angle CRM and angle ZHM are right angles. That's because CR and ZH are perpendicular to RH. So that's a definition of perpendicular lines. Now, we're saying that the triangles are right triangles because that's a definition of a right triangle, because there's right angles in it. Here, CM is congruent to ZM, and that is given. So we're being asked to conclude something because M is the midpoint of RH. But what we can conclude is that RM is congruent to MH. Now we can conclude that the two triangles are congruent. And our justification for that is if we look at the information we have, we're told that corresponding legs are congruent and the hypotenuses are congruent. So by the hypotenuse-leg theorem, we can say they're congruent to each other. That's number 2. Number 3, for what values of x and y are the triangles to the right congruent by hypotenuse-leg? So what we're going to need to do is set corresponding sides equal to each other and find x and y so that the lengths of those corresponding pieces are equal to each other. So let's do that. So x will be set equal to y plus 2, and x plus 1 will be set equal to 4y. So now we're going to need to solve this system. So since x is solved for, we can solve by substitution. So I'm going to substitute y plus 2 in for x in the second equation. Now I combine like terms, I'll get y plus 3 equals 4y. Subtract y on both sides, I get 3 equals 3y. Divide both sides by 3, and y equals 1. To find x, I'm going to substitute y in for y plus 2, since that's already equal to x. So then 1 plus 2 gives me 3, so x is going to be 3. So let's type it in. So x is 3, and y is 1. And that's number 3. Number 4. There are several parts to this one. Starting with A. Graph the points A, B, D, and E, and draw the segments AB, AE, BD, and DE. Label point C the intersection of AE and BD. Looking at each of these graphs, the one that includes those points as the appropriate coordinate for them would be C. D is 0, 3, A is 5, 0, E is 3, 8, and B is 8, 5. Now, the second part wants you to find the slope of segment AE and BD. find the slope of AE, we got to use change of y over change of x, the slope formula. The y coordinates of A and E are 0 and 8. The x coordinates are 5 and 3. So we subtract the y's and put them up top. So 8 minus 0 over top of 3 minus 5 will give us 8 over negative 2 when you subtract, and dividing 8 by negative 2, you get negative 4. So the slope of AE is negative 4. Typing it in, we put in negative 4 for the slope of AE. Now it wants us to find the slope of BD. So again, we're going to use change of y over change of x, but we're going to use the coordinates of B and D. So the y coordinates are 3 and 5, and the x coordinates are 0 and 8. Subtracting the y's and putting them up top, over top of the x's being subtracted, we get 3 minus 5 over 0 minus 8, which gives us negative 2 over negative 8, which reduces to 1 over 4. So let's put that in. So the slope of BD is 1 over 4. Now, how would you describe angle ACB and angle ECD? I would say, since the slopes of AE and BD are opposite reciprocal slopes, that would mean that an intersection is going to be perpendicular, and a perpendicular intersection means that the angles are 90 degrees or right angles. Now it is asking you to write the equation for line AE. So let's find it. So the equation of AE, we already know that the slope of AE is negative 4. We can substitute that in for m because we are going to use y equals mx plus b, which is slope-intercept form, where m is the slope and b is the y-intercept. Now I'm going to substitute in the coordinate for A, because the numbers are easier to work with, for x and y, so that I can find my B. So y is 0 and x is 5. Negative 4 times 5 is negative 20. Now I'm going to add 20 to the other side, which gives me 20 for B. Putting my slope and y-intercept together in slope-intercept form, my equation is y equals negative 4x plus 20. And that's the equation for AE. So my answer is going to be choice C. Now it wants the equation for BD. So let's find it. So the equation of BD, I have a slope of 1/4 for BD. So substitute that in for M. And now I'm going to substitute the coordinate of D for X and Y. The coordinate for D is 0, 3. So 0 goes in for X and 3 goes in for Y. So 1/4 times 0 is 0. So that makes B equaling 3. Now putting the slope and y-intercept together, that gives me y equals 1 over 4x plus 3. And that's my equation for BD. So that will be choice D. Now it wants the coordinates of C. If I go back up to my graph, make this larger, my coordinates for C are 4, 4. So I'm going to type in as an ordered pair 4, 4. Now it wants the length, and to use radicals is needed. So let's find the length. And it says AB is equal to ED. So to find the distance of AB, I have to use the distance formula. And I'm going to use the coordinates for A and B. The x coordinate for A is 5, the x-coordinate for b is 8, so 8 and 5 are going in here. The y-coordinates of a and b are 0 and 5, and they'll go in for y's. So 8 minus 5 is 3, 5 minus 0 is 5. So 3 squared is 9, 5 squared is 25. We add them up and we get 34. Now, 34 isn't a perfect square, so our answer is just going to be square root of 34. So let's type that in. So let's type in square root of 34. Now it wants you to find the length of BC and DC, which are the same length, but it wants you to find what that is. So let's find it. So to find the distance of BC, I got to use the distance formula and use the coordinates for B and C. The coordinates for C are 4, 4. The coordinates for B is 8, 5. So let's substitute in the x and y coordinates. The x's are 8 and 4, and the y's are 5 and 4. So 8 minus 4 is 4, and 5 minus 4 is 1. 4 squared is 16, and 1 squared is 1. Add them up and you get the square root of 17. That's not a perfect square, so leave it as square root 17. Let's type it in. So we're typing in square root of 17. Now the last step, why are those two triangles congruent to each other? So making our graph larger, to show you, we proved with the lines being perpendicular that these are two right triangles. And since two pairs of sides are congruent to each other, one being the hypotenuse and the other being a leg, we can justify them being congruent by hypotenuse leg. So going back down to the bottom, we're going to choose C. And that is number 4.